All right. So this is our first topical study group. It's really just like a review on like the foundations of Python, getting started with data science. I've actually I've actually attached this notebook file in Slack. I think it's like I put it as a thread comment to the study group link for today. So feel free to download that there. Going forward, I'll actually be putting this notebook and all future notebooks onto a GitHub repository, which is what we'll talk about tomorrow. So tomorrow I'll actually walk through the process of, all right, how would you get all of the future study group notebooks so that you don't have to like download or clone every single time. So I'll walk through a process of, getting updated study group notes. And that's how we'll talk about GitHub and Git. So to start, if any of you are curious why I have like these like arrows where I can like collapse things in my notebook, and also this sidebar over here, it's actually Jupyter Notebook extensions. Highly recommend that you get them, especially as you get to the later part of the course. Your notebooks are going to get much longer with your projects. I wouldn't worry about it now if you feel overwhelmed with like just Git and everything, but just so you know, this is a link to a really good article that shows you how to download and configure all of your extensions. And extensions just being like, the functionality of these like drop downs, which just make your notebook a little bit more organized. So if anyone's curious about that, that's what that is. I think everyone here has already set up their environment based on like what I've seen in Slack and what we've talked about. I just wanted to clarify some of the terminology real quick before we get into more of like the Python stuff. So a couple of the new terms that we've seen. First, anaconda. When you do like conda activate, what is that and what does that mean? So anaconda basically manages all of your packages. We're going to start working with packages next week. So things like NumPy, pandas, which are things that you might have seen in your pre-work. Each of those are packages, and Conda just helps you store them in a place on your computer. And if you ever want to like install new packages, Conda has like a library of packages that just make it easier for you to just like, download new information with like one line of code. So that's what Anaconda does. Git, which is a thing that we're going to talk about tomorrow, version control system for tracking all your changes and coordinating code. I think right before this session, I was talking, right before I started the recording, I talked about like what Git is used for. We'll go into more detail about Git tomorrow. Next, Jupyter Notebook versus Python files. So as you can see, like all of the notebooks that we're working with, and if you're like been working on like Illumidesk, everything ends with the IPYNB, the file extension. So IPYNB stands for IPython Notebook. There are basically two different places you can code in Python. One of them is these Jupyter notebooks where, you can put in code cell by cell, and then you can just run each cell separately on its own in order or in any specific order. If I decide to run this cell first and then this cell, I have that flexibility. Next phase, we're going to talk about Python files. So Python files end in a .py. Those are where you can write scripts, and we'll talk about scripts not now, next phase. So don't worry about that. But if you do see like a file that ends in a .py, it's basically like, it's pretty much like a Word document where you can just throw all of your Python code in. And I'll talk more in the future about how we use those. Next, in the setting up of your learn environment or of your environment, you would have set up this thing called a learn environment. The concept of an environment, I think, might be a little confusing now, but what it does is it downloads a specific version of every single package that we need for this course. Not even every single one. There are going to be a couple packages that you have to download on your own, and we'll get to them later. But the virtual environment makes it easy for students to get started so that you don't have to install different packages as we get to them. By doing that step of downloading the virtual environment that you all did in like the first topic and setting up the learn environment, that just means that in the future, when we get to like work with, 10, 20 packages, they'll already be installed on your computer. And yeah, there'll be the versions that, the same versions as the versions this curriculum was created with, so you don't run into like conflicts or anything. Much later, we'll talk about how virtual environments are used and how virtual environments can help with your like project. Oh, what's the word I'm forgetting right now? Like if something gets My brain's a little scattered. Basically, when something changes, like if a syntax for a method changes, or yeah, can't think of the word right now, but I will remember one day.
Like desynchronize or something?
Something very similar to this desynchronize. Huh. Okay, I'm blanking on the word right now, but not super important for now. When I remember it, I will let you all know. All right. I don't know if anyone had a bunch of issues when setting up the environment. I think we've recently done like an overhaul of those instructions. So I think you all have managed to successfully do your environments, hopefully. If you run into anything, just let me know. But these are just some of the common errors and fixes that like past cohorts were running into. But I think you all should be okay.
Thank you, Nelson.
Huh?
Thank you, Nelson. I just want to say thank you to Nelson for helping me.
No problem. Always happy to help.
Awesome. I'm so glad that you all are helping each other out. Yeah. If anyone is running into anything, I would like to reiterate that feel free to send like screenshots or messages to the Slack channel or directly to me whenever you like. I will also tell you for the next 4 weeks as I'm working Asian time, like in Asia, I'm very, very bored at night, like your nighttime. So please send whatever like questions you run into so that I have something to do. Any questions regarding the environment kind of stuff before we move on to like Python? All right, so let's talk about these. I would say these are like the foundational elements of Python. We have data types and then collections, and then there's going to be a little bit of like logic flows. So in data types, we'll talk about strings, numerics, which are just numbers, booleans, true, false, and variables. I'll go into each of these in a little bit as well. In terms of collections is where you can group your data together. We have our lists, dictionaries, sets, and tuples. And I have, again, later on in this notebook, examples that you can play around with. And then at the end, if we have time, we'll talk about some logic flows. If you would like to download this notebook, I think if you're not feeling comfortable with any of the data types here, this is a good notebook, I think, to just download and play around with. You can, mess with variables, mess with like the lists, dictionaries if you're having trouble with that. Cool. All right, to start, let's just start easy with data types. So first we have strings and string methods. The link I linked here is to W3 Schools, which is I think a really great resource for, I don't know, I think they collate a lot of resources and a lot of like documentation in a really easy to read way. So just an overview, a string is basically like anything in quotes. If you want to like store your data as like a word or like a long phrase or a sentence, it would be in a string. Strings and these other Python data types we'll talk about in a little bit, strings have a lot of methods. I open up this tab to just show you all how many different methods are built into Python just to work on strings. So here you can see we have like capitalize, we have count, we have, I don't know, what's one that we use? Replace is one that I have in the notebook in a little bit. Lower turns everything to lowercase. There are so many methods. One thing that I want to reiterate is nobody memorizes all of these methods. Some people memorize a few. I think I have like maybe 10 just in my head because I use them often. But you don't have to stress out about like memorizing, okay, strings, you can do this, this, and this. Just so you all know, you're not expected to memorize any of these at all. But yeah, I like this W3 Schools website for documentation just because it's easy to read. Like for example, here I have, I'm doing this dot replace over here, and if I'm confused as to what's going on here, I can just look up, all right, where's dot replace? Dot replace is here. If I click onto it, it'll show you specifically how it works. So here you can see the syntax, and syntax basically means how do you use a method? And so you can see here, you would do a string, dot replace, old value, new value, and count. And as you can see here, these are called parameters. Some of the parameters are required, some of them are optional. So count, well, old value, new value for replace, you're basically replacing an old value with a new value, so you just tell it what it is. And then for count, how many times you want to replace an old value with a new value. So I just think this documentation is easy to read. If you're, it's a really, really good skill to have, like getting to know documentation and digest documentation. It can be very, very intimidating to start just because there's like a lot of tech speak here, but I think it's worth going through for sure. All right, so just as this quick example, I'm using dot replace, and as you can see here, old value is the letter O, new value is the letter X, and here I just put 2 for 2 times. So what this is going to do, it's going to go through this entire string, look for the first 2 O's and replace them with X's. And so when I run this, you can see that the O's here were changed, these were not. If I take away the 2, it'll do it for all of them. So all of the O's became X's. Strings have so many methods. I think a lot of the methods you also wouldn't expect. So if you ever need to do something with a string, I think it's a good idea to just like look it up, Google it, even though you can do it like, you know, by hard coding it out yourself. It's sometimes a lot more efficient to just use a built-in method because these are actually all built into Python already for you. Questions regarding strings? All right. Okay, so next we have numbers and just general math. When I first started learning Python, I thought the coolest part about it was that I can use like a calculator, which is pretty much what you can do. So the main numeric data types here we have are integers and floats. Later, when we get into pandas, you'll see that it's important that you distinguish between integers and floats. Integers are basically anything without decimals, like without like the point whatever, and floats are numbers with decimals. So that's the main distinction between them. You can perform math operations. So for example, let's do this one first. You can just do like 1 + 5, it'll evaluate to 6. 5.0 is a float. So another thing that will be very useful for you all is if you just wrap a value with type, it'll tell you what type it is. So 5.0, you can see here, it tells you it's a float. If I just do 5, it's an integer. Something that's pretty neat to know is if I add a integer with a float, so 5.0 + 6, it automatically converts it into a float. So the result of any operation between a float and an integer will be a float. Some other useful math operations, I will say these are operations that are not like in the math world very typical, but in data science have been pretty helpful. Modulo, which is the % sign, gives you the remainder when you do division. So 8 modulo 3. So if you remember like simple division, 8 divided by 3, you get 2 with a remainder of 2. So modulo will basically give you the 2, the remainder of 2. So here it'll give you 2. If I do modulo 4, you get 0 because 8 divided by 4 is 2 with no remainder. So modulo is sometimes something that's really helpful, especially if you have a task like checking if something is even or odd. You can just check if something modulo 2 is equal to 0 or not. Another pretty helpful one is floor division, which is the / sign. That just gives you like the quotient. So in this case, 16 divided by 3 will give you 5 with a remainder of 1. So this will just give you 5. There are a lot of different math operations that you can do here, but I think these are like the main unique ones other than like multiplication, subtracting, division, addition. So yeah, these two, modulo and floor division, are the more, I don't know, unique, useful ones. Any questions here? Sweet. Okay. So next we have Booleans and like logic. So Boolean usually just true, false. Logic is when you bring in multiple Booleans together. So if you have like and or operations and not operations, these are all keywords in Python. One thing to note here as a mini tangent is if you see any word turn green in Python, it's a keyword, meaning it already has like it already has some sort of meaning in Python. So you shouldn't name any variables, something that turns green. Anyways, here we have true and false, which as you know means true or false. And if you use the and or operator together, you can end up with like a lot of crazy combinations of trues and falses. I will say that this gets more important later during interviews because Python interviews, whenever they give you like coding interviews, they like to test logic sometimes. For now, you probably won't be met with big logic questions. But basically, if you have something that is true and also true, you end up with true. If something is true and false, you end up with false. It's just playing around with the different combinations of and or. I will say this is a really good one to play around with. Something I forgot to put here. Let's say, is it equals to false? Let's see, let's split this up into a couple different ones. So one thing that you can play around with, all right, is it will evaluate to false. If we do is it and false, evaluates to false. Is it or true, evaluates to true. And if I put a not in front of anything, it just reverses it. I know it sounds like I just spewed a bunch of gibberish in the past minute, but yeah, this is something to just play around with. If you ever want to check for multiple conditions in like an if statement, this would come in handy. But yeah, it'll be a lot easier to understand with like concrete examples later on. So yeah, you can definitely play around with these. So not true becomes false because it reverses. This is just good to know, but any questions regarding like Booleans and logic?
There was some, I'm not seeing it here, but there was something else. I'm not sure if it was like the falsy, truthy values. I'm just,
Ooh.
that's, I feel like I have a question. I just don't know how to formulate it because I just don't see it here. I forgot what how they phrased it in the, because I remember during the pre-work that I struggled with that actually.
Okay, yeah. I will admit that like falsy and truthy are very, very confusing for me as well. I would like to see the example. I haven't seen the pre-work in a while, but I'll, if you find it, send it.
I'll look it up and I'll send it to you because
maybe send it to the channel so we can all see.
Okay. All right. I will do.
Awesome. Yeah, falsy and truthy is basically like it's kind of true or kind of false, but I always forget like what the main difference is. I will say like as a data science coder, you don't run into a lot of like falsy or truthy scenarios. So not a big thing to worry about, but it is something that's good to know for interviews. I will admit that. All right, before we get into collections, let's talk quickly about variables. So you can assign anything to a variable and then just, it sort of works like an alias. I like to think of it as an alias for what it is you're assigning to it. So here in this cell, I've assigned 5 to 7. Let's change that back to 5. I think I changed this for a different class. I assign 5 to 5, 8 half, 8.5 words, and then a Boolean here. So I run this, and basically this just works like aliases, right? So 5 plus 8 half is going to do this, this addition here. You end up with 13.5. Using words, I can do my string operations on a variable that has a string. So I can use dot split. Dot split is another one of these methods that is in this list over here. Dot split. And then not is it, I think I did that above. Yeah, just works as a proxy. Something else that you can always do if you don't know or if you forget what your variables are assigned, one, you can print them out, but also what you can do is, again, use the type use the type function to just check what type is. So let's say I want to do, okay, what's the type of 5 plus 8 half? It'll end up as a float. So I think the type one is something that I actually use a good bit, especially when I'm like inspecting my data. All right, I feel like a lot of this should be review for you all. Feel free to like Slack over any questions that you have, but any questions before I get into collections? All right. So the next few things I'm going to talk about, these are all different kinds of collections, and they're just basically ways to like store a bunch of pieces of data in one variable, for example. So lists, there are a couple keywords that you can use to characterize the different collections. So words that I use to characterize lists is that they are ordered and also mutable. And we'll talk about what each of these mean in a little bit. So let's just say I create this list called my list, and I put all of these things. One thing that's pretty neat is that in a list, I don't have to like make all of the elements the same type. I can really put whatever I want into a list, which is pretty neat. The thing about lists that makes it ordered, well, lists are ordered, and one perk about it being ordered is that you can use indexing to pull out its elements. So using indexing just means that you can pull out a specific element based on where it is in the ordered list. So for example, if I want to get the third element, third beginning with 0, just so you remember, when something is indexed, it actually starts with 0. So the first element will be index 0. Let's say I'm pulling this out, I can just put in square brackets the number or the place where the element is in the list. So let's say I just want to figure out what's the fourth element in the list. It is 3. All right. With lists, there are also a bunch of operations. If you look up the W3 schools, let's see, W3 schools lists, you'll see that there are a bunch of different operators and methods that you can use on lists. So here, they don't have it all in like in a nice list like we had for the strings, but you can see here that you can do type, oh wait, hold on. Python list methods. Here we go. This should have all of them. There we go. So we have like append, we can do extend, remove, all of these things we can play around with lists. All right, so back to this. We're going to talk about what a destructive method is. Append is an example of a destructive method. Just an example, a destructive method means that it actually changes the variable. So when I'm appending 8, it actually updates the variable my list to have the number 8 at the end of it. So if I run this, you'll see that my list has the number 8 at the end. And just to check, if I were to run my list again, the 8 is still there. What's a non-destructive method? Doing something like this. So let's say I just do my list plus 9, 10. Let me comment this out first. Oh, by the way, the shortcut for commenting something is Command or Control and then the question mark button. That's just a quick way to comment out your code. So let's say I run this cell. If I do my list plus 9 and 10, that's something else that you can do with lists. You can just add lists together. You can see here that it adds 9 and 10 to the end of the list. However, if I uncomment this, and basically in a Jupyter notebook, what it outputs is basically the last line of any cell. So let's say I output my list even after I do this addition. You'll see that the 9 and 10 isn't there anymore, or it actually never was there. It never was added to the my list variable. That makes sense. So just doing this addition is a non-destructive operation, whereas doing the dot append actually updates the variable my list. Cool. So another method that is kind of similar to a dot append. A lot of people get confused between dot append and dot extend, but there's another method called dot extend. It is also a destructive method. And I'll talk about what the differences are in a little bit. Dot extend is another destructive method, and it just, oops, here, I need to do this first, and I'll explain why. It just adds another E. So to just talk quickly about dot append versus dot extend, dot append will just add whatever you have in here as a single element to the end of the list. So let's just create a new list. Let me just start from scratch here. So let's say I have this my list here. Let's say I do my list dot append, And let's say I want to append multiple things. I can do, let's say I want 8, 9, 10. So I do my list dot append 8, 9, 10, and I run it. Oops. Let me just do this again. So you see here what happened is it actually appended this entire mini list as a single element to the end of the list. So if you ever wanted to do multiple things to an end of the list and have it like continue the long list rather than adding a list inside of a list, that's when you would use dot extend. So if I just change this to dot extend and I rerun this from scratch, so this is now back to this, I do dot extend. You can see here the difference between dot extend and dot append is extend just extends the list versus adding a new element to the end of the list. That's just something that not many, I think I like learned about dot extend like way too late. So I think that's a useful one to know. Any questions about this? I feel like I just like introduced a bunch of things. So yeah, you can take a short breather. Sweet. All right. Okay, so let's just see what my list is at now. Okay, so let's stay with this. A list is also mutable, which is something that I don't think I have an example here. But a list being mutable means that you can actually change its elements. So let's say I have this list here with like the 8, 9, 10 at the end of it. Let's say I want to change this 10 to be the word 10. What we can do is my list index 10 equals to 10. That just reassigns the 10th or 11th element of the list to instead of the number 10 becoming the word 10. So that's basically what it means by being mutable. When something is mutable, it just means that you can update the values. Later on, we'll see a data type that is immutable, and we'll see what kind of errors we get there. All right, so those are the two main properties of lists. Other things that you can do with lists, you can also iterate over lists. That's something that you are probably going to be doing a bunch of. So just really quickly, I know like loops are a little bit more of like topic 3 stuff, but I think it was also in the pre-work. Basically, to loop over something, it goes over every single element. You have this variable t. I like to think of t as like a temporary variable that just moves down the list. So for t in my list print t, it's just going to print every single element. Something that's also going to be pretty helpful sometimes is using list range length. So let me first run this cell and then we'll talk about what list range length is. So you can see here, these two loops look completely different. Well, it looks different, but it prints the same result. This is sometimes useful because this is looping using the index of a list. Let's break this up first. So we have my list, which looks like this. And there's a bunch of nested methods being used here. So in this list, we have a length of, it should be 10, I think at this point. Oh, 11, excuse me. So we have 11 items in this list. And if I wrap it with range, you basically get range of 0 to 11. Like this is not helpful, but let's use the list object. And now we basically have a list of 0 to 10. Sometimes, and we haven't been faced with scenarios yet, but we'll see later on that sometimes it's more useful to use the index of something to loop through versus the list itself, the list's elements itself. And so this is just a different way of looping through a list. I can just, for I in range length my list, and range length my list is basically the numbers 0 through 10. I can print my list indexed for like whatever I is. So basically this temporary variable I is going to point, it's going to read as 0 and then 1 and then 2 and then 3. And then it's just going to print based on the index. So something that's just good to know, I think, that this is just an alternate way to loop through a list. Questions here? All right. I also recognize that this might be information overload. Whether you've seen this yet or not, we are jumping around a bunch of different things. All right. Next, dictionaries. Dictionaries are a little bit tough to work with. Main characteristics of dictionaries is they are key value pairs. So this is just a dictionary that I have here called my dict. I have keys, which are brand, model, year, and then values. Ford, Mustang, 1964. Some main things about dictionaries that you should know is they are not ordered. So you cannot actually index a dictionary. And they're also mutable, just like this. If I want to update any values, I can do that. So let's look at some things that we can do with dictionaries and some of the methods that will make dictionaries useful. So I have this dictionary here, super simple, just 3 key value pairs. We just print this. You can see that I have this dictionary here. A few built-in methods that are going to be really useful. Dot items. So dot items just turns a dictionary into a list of tuples. So just as an example, here I'm printing the type of my dictionary, which should be dictionary. If I print the type of my dictionary.items, you get a dictionary items data type. If I turn my dictionary into a list, something that's good to know is it actually only keeps its keys. So therefore, the dictionary items can be useful because if you just turn a dictionary into a list, it only keeps its keys. If you want to save the keys and the values as well, you would use dot items. So just as a little precaution, oops, and back. If I ever wanted to keep the keys and the values together and turn them into something that I can actually iterate over, I use list mydict.items. And so therefore, this is now just converted into a data type that I can then loop through. This is just because dictionaries are not ordered to begin with. This just makes them ordered. So then if I were to loop through my dictionary and print I, for I in my dictionary, because if I convert a dictionary straight into a list, it remains as just its keys. The result is just going to be the keys, which sometimes you want, sometimes you don't want. But if I did for I in my dict.items, the difference here is that you get the key and values together. And sometimes you just want to preserve that relationship between the key and value, which is why dot items is going to be very useful. So really quickly, if I do the type of each of these, and we'll get to tuples at the very end, we'll see that each of these is actually a tuple, and we'll get to tuples after the next data type. All right. You're probably going to end up creating a lot of new lists and dictionaries. So just really quickly, how do we do that for dictionaries? We'll do this in 2 ways. So first I have this, I'm going to make 2 empty dictionaries, one just called new dict, one called new dict 2. One way to do it, and I just want to repopulate these dictionaries with the same information that I had at the start. Again, feel free to take this notebook, download it, and play around with the code. I think that really helps understanding what's going on. But yeah, for I in my dict.items, and just so we remember what that is, let me just output that here. I'm going to assign, I'm just going to recreate this dictionary in this variable here. So what I'm doing is I'm calling the dictionary what key I want, and then what value I want that's associated with it. So just to put here, I'm going to call the dictionary variable key equals to value. And this is how I create or update an element in the dictionary. So what I'm doing here is I'm looping through this old dictionary here. And if you remember, if I'm looping through dot items, it actually becomes a tuple. So there are 2 elements in the tuple here. So here I have the first element of the tuple, because this is I0 and this will be I1, assigning it the associated value. This is something that I would definitely recommend like playing around with if you're not very comfortable with dictionaries yet. But as you can see here, this has successfully made our new dictionary from my dictionary. Questions? All right. This I'll skip for now, but another way to do this is when you have your dot items, this is introducing something called unpacking. So in the my dictionary dot items, and let's output that again. If you remember, and actually let's turn that into a list so it's less distracting. So we have a list of tuples here. If I'm looping through this, each time is going to give me a tuple, right? Each time this I points to a tuple. Python has this really neat thing known as unpacking, where if you have two elements in each element, you can actually assign two different temporary variables, which for some people can be confusing. I will admit that for me, it took like maybe like 2 phases before I got comfortable with this. But I can do for k comma v in my dict.items. Basically what that means is I have two temporary variables, one that always points to the key and one that always points to the value. So that's what k and v stand for. That's one of the usual variable names it uses here. And then I can just do the same thing. So here, instead of doing like I0 and I1, I'll have k and v. And then the same thing happens. Just to make this a little bit clearer, we can actually print the key is k, and then I can also print the value is v, so we can really see what's happening here. Actually, no, let's put this all in one row. This, format it right. Okay, here we go. So when I run this, you can see here that the key is brand, the value is for, because these variables are automatically unpacked to the two elements of the tuple. If this doesn't make sense right now, don't worry about it. I would say this is a little bit more advanced. It's a little bit more advanced looping. So yeah, with the mydict.items, you can also do the same thing. If you do like range length, it'll also give you like 0, 1, 2. The main thing is to know is that when you do a dot items, that's actually going to be something that's pretty helpful. It just turns a dictionary into a list of tuples, which will be sometimes easier to work with, especially if you need something to be ordered and dictionaries are not ordered. Questions so far?
Quick question.
Actually had a go ahead,
Oh,
Amir.
go ahead. No, go ahead. I'm always taking over. Go ahead.
Oh, you're fine. But essentially, I just had a quick question. So for when you did like k comma v in my dict items, I saw that you did new dict 2 and then the k and then equal v, but you didn't put the new dict 2 with the v. Is there a reason why it wasn't like that in the other one, or is it just something kind of quirky, it just kind of happens sometimes?
So whenever you're adding something new to a dictionary, that's just the syntax for it. So let me just copy and paste that here. Whenever you want to add something new to a dictionary, you use the dictionary's variable. So here is like the new dict 2, the key, which is k, equals to the value.
Oh, okay. Okay.
So similar here, I didn't call new dict a second time here. Yeah. All right, who else had a question?
Quick question. This is, I guess, a hypository, but like, would there ever be like maybe not, it's not a dictionary item, but let's say you had a method that returned like 5 different values, or I don't know why I'm getting this in my head, but maybe like a list. Could you use the same like 4 variable, let's say there were 3 in a list, and then like access all 3 if it was being returned?
Yeah, so one example is, let's just do a really quick one. Let's do like 1, 2, 3, and then 4, 5, 6. So yeah, Python does unpacking automatically. So you can do for X, Y, Z in list print, let's do X plus Y plus Z. So you can see here, it actually does the unpacking
Okay.
for you. One thing to note, if I had like something that was like inconsistent and I had like random numbers there, you end up with not enough values to unpack.
Okay, thank you.
You're welcome. Mo, did you have a question too?
Yeah. Why is the key bracketed?
Why is
The
the
K, the K bracketed, sorry.
Here, right?
Yeah.
Okay. It's really just the syntax of it. I think it's trying to follow, let's say if I had the dictionary here, it's trying to follow the same syntax of, let's say I wanted to retrieve a value from a dictionary. So let's say I have this dictionary and I want to get like just the model name. The syntax for doing that is putting the key in square brackets. And then if I do that, I actually get the model name. So I think it's just trying to mimic that same syntax. Like if I wanted to create a new key, so let's say I wanted to store the color of the car. The way I would do that is I would do my dict color equals to red. And so if I did that, and also one thing I guess I should mention is that every time I do this, it's also destructive, which means that it actually changes the variable. You can see here that it's added on the color red. So doing this in a loop is basically doing this over and over again. So I know it throws a lot of people off because like the K is not a key, but it's just a temporary variable that holds the key. But what we're doing here is basically what we're doing here. Does that clarify?
So I'm just like kind of confused why the V isn't bracketed as well.
Mm-hmm.
I don't. That's because I
Yeah.
saw if you scroll further up, like it's bracketed here. Yeah, that's why I was.
Yeah, that is pretty confusing. So you see here, there is actually 2 layers of brackets in this first part. So you have I index 0 being bracketed here. And then here, there's like no bracket around I index 1. It's really, again, just following this syntax. I know it's just this syntax, but in different forms can get really confusing. But yeah, it's really just because this is the main syntax for adding values to a dictionary or adding elements to a dictionary. So yeah, pretty much only the key gets bracketed. The reason why there are brackets in this one is because we're updating the dictionary with a specific element of the tuple. So there's a lot of things going on in this cell here. But this inner bracket just comes from the fact that we wanted to extract, here, we wanted to extract the 0th term and then the first term separately.
Yeah, okay, now that makes sense.
Yeah, it takes a little, it honestly does take a little bit of getting used to. Yeah.
Thank you.
No worries. I told Jack this story earlier today, but like when I was a student, I went on a rant to my instructor about how dictionaries are stupid because they're like not ordered and you have to do all this like extra stuff just to get it to, iterate over, which is what we do a lot of in Python and data science. The argument that my instructor came back at me for is dictionaries are actually the most efficient way to store your data if you need it to retrieve it very quickly. This is not super important for data science, but when it comes to like algorithmic efficiency, like how quickly does your computer work to find something? If I wanted to retrieve like the brand name from a dictionary, like my dict, and then I do brand, this is actually like an immediate process. Like the computer just knows immediately, okay, if I want the brand, I know I can just look up where the brand is and then give you the value associated with it. If instead I stored this as a list, so let's say I had, where did I put that? Let's say I had this. If I wanted to get the brand, it would be a lot more difficult. So just as a quick example, let's just call this dictionary list. If I wanted to get like Ford out of here, I would have to do like for KV in dictionary list if K is equal to brand print V. And then that's how I get Ford. The difference is for a list, you actually have to like traverse through every single element. So like, all right, is this the brand? Is this the brand? Is this the brand? Versus a dictionary where you can just immediately, all right, I stored this key as brand, I can immediately get it out. So this is how it was. And now I appreciate dictionaries, but it was very, very tough to work with when I was first starting out as well. Cool. That was a little nice tangent that we went on. Let's see what else is here. And we are about 5 minutes in. I will say I think we can finish this out in 5 minutes. All right. All of that just now was just showing why dictionary dot items is very important, especially for making a dictionary iterable. Next, we'll look at dot keys and dot values, just other important things that you might need to use. Every dictionary comes with a keys method and a values method, and this just returns you the keys and the values. So sometimes you just want to get all of the keys of a dictionary, that's how you get it. If you just want to get all the values, that's how you get it. The type of these are actually keys and values. What this means, not too much, is just that it's a different data type from a list, but it kind of works the same way as a list. So you can print all the keys, print all the values, and this, once you get it in this format, it just makes it iterable again. It's really all of these dot keys, dot values, dot items just helps you make a dictionary iterable. So then you can then index it. So one of the main characteristics that we've been talking about is whether something's iterable or not. So lists are iterable, dictionaries are not. Dictionaries not being iterable is actually what makes it so easy to retrieve information so quickly. But downside is you cannot like loop through a dictionary as well as you can with a list. So just some functionality there. Okay, so this last part, I think we'll end off here because control flows we will talk about next week. Let's talk about sets and tuples. These are a little bit less used, but still good to know. So a set is actually very, very similar to a dictionary in which it is not ordered as well. The thing that's unique about sets is that the values are unique too. So let's say I create this set of 1, 2, 3, 3, 4. The set will automatically get rid of the duplicate 3. That's actually something that's unique to dictionaries as well. You cannot have a dictionary with 2 of the same keys. If you try to do that, it'll actually overwrite the first of it. So let's say if I like try and overwrite, like, let's say the car has 2 colors and I wanted to update, let's see, where's that code? So here, let's say I wanted to add another color. Maybe it is red and blue. If I run this cell, you can see that it doesn't add on another color. It just updates the color to be blue. So if you wanted to have 2 colors, you would have to have 2 different keys, like color 1, color 2. So that's what's similar about lists. That's what's similar between dictionaries and sets. All right. So sets not really used too often. If you want to ever get like unique values of something, let's say you had like a list and you want to get the unique values, you can turn it into a set and it'll give you all the unique values. And then next we have tuples. And the main difference between tuples is that they are immutable. So tuples are sort of like lists in which they are ordered as well. So if I have a tuple here, my tuple 1, 2, 3, I can also index the tuple just because it is ordered. So I get the second element there. It is immutable. So that means I cannot update values in a tuple. As an example, if I try to update this to the number 4, it actually will say that tuple object doesn't support item assignment. You cannot reassign tuples. So if you ever wanted, your data to not get messed up, and we'll see later on in the program where you might want that, you store it as a tuple. Cool, awesome. We are right at time, but I don't have any meetings right after this. Does anyone have any questions? All right, well, this notebook, I have linked it in the Slack channel. I will tomorrow show you all how we're going to deal with all of these study group notes in a more organized way when we get to Git. And yeah, I know it was a lot of information today. Even if you're like familiar with all of this stuff, I think like jumping between all the different data types and like collections can be very overwhelming. So just if you want to, feel free to play around with this. I liked having like a playground like this just so I can, mess around with code and see what happens, see what kind of errors come up, rather than working through the labs, because working through the labs is sometimes, you're following like a longer problem. So yeah, feel free if you find that this was helpful to take this notebook, download it, open it up and mess with it. Something else that I wanted to mention is if any of you all for the next month, because I am in Asia, if any of you all want to have later one-on-ones, feel free to Slack me and let me know. The sun is actually just rising right now, and so I'm so bored the rest of the day. So if you ever wanted like evening one-on-ones, Slack me and let me know. I've already arranged it for a couple students, so if you would like that, Slack me. And it doesn't show up on my booking link, so let me know if a later time works better for you. All right, well, any last questions or thoughts? All right, well, tomorrow we're going to play around with Git. And yeah, any questions as usual, feel free to Slack me, the channel, let me know. All right, then have a good rest of your evening, everybody. I'm gonna post this recording in a little bit once it gets uploaded onto YouTube.
Thank you so much. Have a good night, everyone.
You're welcome.
Good night.
Bye.
Good night.
Thank you.